again, that's what you're looking for, but it's not only that, because I'll talk about how we want to collect these microbes as well. You can see, I call them the woolies or the fuzzy wuzzies. That's, we're going to keep that on there as well, because it actually, there's a space in that box, there's a bit of a space cavity in there, and that stays a little bit more humid. If I leave that off, that will just like wilt very quickly. So, okay, so indigenous microorganisms. The idea is that we want to collect microbes from around in the same bioregion that we're growing plants in. Not only growing plants, because this is something that you can use for your livestock as well. That's a part of it is a deep litter system that we won't really go into today. But we're collecting microbes that are adapted to the area that we live in. And the idea is that you want to collect them at different times of the year, at different areas, but try and go to get as much diversity as possible, but try and go into areas that are undisturbed, or as undisturbed as possible, because what they found scientifically is that there's a lot more diversity of microbes in those areas. So you can see that we have rice in there. Rice is a food source for those microbes, and we cook it in a certain way. You basically half cook it, so it's not gluggy. If you get gluggy rice, then everything below the top surface is actually can go anaerobic, and that's not what we're going for. So the white fuzziness, those woolies, that's what we're looking for. That's a good indicator. That doesn't mean that it has a diversity of microbes necessarily though, but it's a good indicator that we're heading in the right direction. Another thing is that we've got a natural box here, a natural wooden box. It doesn't have to look too pretty. I could probably take a box making course, but it does the job. It has a little bit of an air space in there. We've got the rice in there, and then I wrapped it in this Hessian bag as well. This one, I did a couple of other collections, and the ants just got to them, and it's just the ants this time of year. I have these little red ants. I don't know if you've seen those ones. They just get into everything. This one I was pretty happy with. We want to have a wooden box too that's untreated. In Korea and in the States they use cedar boxes for a couple of reasons, because the cedar doesn't rot so much, break down from the microbes being in there. But it also helps select the microbes that are coming into there. The cedar, well, that's why they use them in saunas, is because it has an anti-fungal property that stops it from rotting, and only certain kinds can sort of propagate in there. Now there's other things that you can use other than rice. That's varying off from the Korean natural farming method into some of the other methods that Richard has in the book. There's lots of different natural farming methods. I'm just focusing on Korean natural farming. For me, I like it because I like the philosophy, and I like the process, and I want to get the process right before I start. I mean, I do play around a bit, but before I really get off into other things. Like I said, Rich has got some great stuff about the fermented clay. I really like those processes that he's got in the natural farming book there. And I'll plug that a little bit more. There's actually, was it five of you wrote that together, wasn't it? You,
four main.
Ray, Drake.
Yeah, and Luzine, who's a Filipino.
Okay, yep.
And there's lots of other contributors in the book.
Yeah, yep. So they sort of wrote a book, and this is really for really low-cost natural farming, subsistence farming. This is relatively low cost as well, but you do use sugar in a bunch of different things, which I'll talk about in a minute. And depending where you are, maybe sugar's not so easy to get. Here, it's not such of a problem. But the microbes. That's what I really want to focus on. It's the microbes. We collect the microbes. We select for microbes through ways that we can test without a microscope. So looking visually for that white fuzz. You don't want to see black fuzz going on there. There's other colors are okay, but when you see that white fuzz, it's an indicator of what's happening in that environment. Now, when we go out and collect it, like I said, in undisturbed area, you want to find like a nice big tree that's been in that place for ages and really sort of undisturbed. Bushland would be here, where there's a really thick layer of leaf matter, and a good indicator for finding a good place is you dig down and you actually see mycelium. You actually see those strands of hyphae in the ground. That's a good indicator that that's the right area, the right kind of balance of microbes to lay your trap and get those microbes.
Don't be afraid to get down and put your nose in this.
That's right.
And
yeah.
smell.
Yep, that's right.
Smell is a very good indicator of what's going on in the soil.
Yeah. So when you do get down there and smell, you should smell that. Everybody knows what good soil smells like. That fresh, sort of fungal, foresty smell. Yep. It's similar to when it rains. You smell that fresh smell. That's Actinomycetes. That's one of the good microbes in there that actually releases scent molecules. So we're collecting those microbes, and from what I was talking about before about being present and doing it with intention, that actually makes a difference. That makes a difference to the whole process of like, okay, I'm doing this, with an honoring spirit, with a respectful spirit of like, I want to partner with the microbes here to create something, create life. So we've got this IMO. We call this IMO 1, and then what we're going to do with that IMO is mix it in with some sugar. One part by weight, one to one sugar to one microbe collected rice, and that will create IMO2. So you can see I have 3 different collections here. We have a few more, but these are some of them that I did there.
So how much water? Because there was
There's
one
no
part
water.
Sugar, 1 part rice, so there's no water.
No water.
The sugar
There's
doesn't-
there's enough moisture in the rice
That's right.
to extract it.
Yeah.
Oh.
So
The other
Sugar
thing
doesn't
is you're
kill
not
microbes.
using white sugar, you're using raw sugar or brown sugar because they contain minerals.
that's right. So have a smell of that and pass it around. And here you go. Can you have a smell of one of these ones?
So it's white sugar, is it?
Not white sugar, raw sugar, which is actually white sugar that they've added molasses back to, or real jaggery, or real
sugar in here.
real brown
Wine.
sugar. Yeah, that's right. It can be anything.
How did you do your collection? Did you take the box and you sprinkle you pick up soil?
Oh, sorry, no.
Did everybody have a smell?
I didn't explain that, did I? Very well. So I got this box. I put it in the Hessian bag, and then I placed this in that area under the tree, and left it there. So we're not going to get into everything, but basically you leave it there. You want to make sure there's a little bit of airflow, but sort of half bury it in the leaf litter. Leave it there for, this was 3 days because it's hot. It could have gone another day. In the winter time, you want to leave it a bit longer because it takes a bit longer to get going. You come back and you have a look at it, and you'll see, if you see a good indicator like that white fuzz, then you're like, yeah, we're on the right track.
Just leave it
A
there.
bit like grapes or
Sorry?
That's lid off
No, in the bag.
in the bag.
In the bag,
Yes, it's
in
restricted.
the under the leaf litter.
that is a microbe, but I
Summarise
can't remember
then,
which one it
you
was.
put your rice in, your sugar, you put everything
Yeah,
in.
there's one that gives off a grapey smell.
No, sorry. The sugar is for IMO 2. That doesn't have to do with IMO 1. We're just going over IMO 1 was putting that cooked rice in the box under a tree, leave it for 3 to 5 days to collect those microbes. After that, I'm going to go for a hike or wherever, pick my box back up, bring it back, and then I'm going to mix it 1-to-1 with sugar, raw sugar or brown sugar, and put it into a vessel like this. So
Water.
no water, no water. What happens is the sugar actually draws the liquid away from the rice and the microbes, and that's putting them to sleep basically. And 1-to-1 seems to be a good ratio. That there's still a little bit of moisture content, but not enough for the microbes to. There's a little bit of moisture content in there, so they're not going to completely die. But there's not enough for them to actually actively breed up. But when you put the sugar in there, most of those sort of microbes will sporulate, or go into some sort of hibernation state, and then you can keep this for about a year or so in that state. And then we're using this as an inoculation to breed up the other kinds of steps of IMO. So this is IMO 1, this is IMO 2, and then we come to IMO 3, which is where we really start to breed up those microbes. So these are the microbes in stasis, and what I found is playing around with, similar to what Richard does, is I use these for making bokashi as well. Has anyone know about making bokashi or made bokashi before? Yeah, so instead of using EM, you could use something like this, and that works really well actually. In fact, it works so well that I'm starting to make some bokashi to sell just on the side, because I do some composting stuff. So, this is like the seed. This is the seed for making our microbial inoculants. This is something that is relatively shelf stable. When I first put it in there, it started to bubble a little bit, but now it's settled down a bit. So if you do have a closed lid, it's advisable just to leave it off just a little bit, except just beware of ants. Ants get into anything. So yeah, you want to have a bit of space in there as well. That's sort of part of the finesse of doing it, to collect them well and look after them well. Obviously you don't want to have them in sunlight. Sunlight's going to destroy the microbes. But we're going from IMO 2, and then we're going to breed them up into IMO 3, which is, you can see this is completely dry now, IMO 3. But what we've done is we make a pile. I'll find a place on the ground. We want to have it on the ground, and make a pile with some food for the microbes. So in here we've got some cracked oats. Cracked oats is a carbohydrate source. We have some meal run or meal mix, which is basically fractions of, it's horse fodder. You can buy it at a feed store.
Yeah, we found that pollard was the same sort of
That's
material,
right, yeah, pollard, yeah.
which you can just buy in Coles and
That's right,
the other
yeah.
places,
And
so
it
you don't have to go
doesn't
to
matter if it's
feed.
non-organic?
Well, I mean,
You've not had any problems out, I guess.
we haven't had any problems. The thing about the microbes is they can break down a lot of those chemical constituents anyways, although if you can help it, you don't want to have lots of stuff with glyphosate on it, but use what you got, right? That's one of the main things about natural farming, is using what you have. So in Korea, and you can probably get too, is rice husk.
Plenty of it.
Yeah, so that's got the carbohydrates in there, and it's got the carbon sort of source. So we mixed up that with a bunch of other things that I won't really go into. There's some of these inputs in there, but we get all this dry material, put it on the ground in a mound, then get some water, non-chlorinated water, and some of the other inputs, mix some of the IMO2 into that water, stir it up, and then we're pouring that water onto the dry material. Has anyone ever mixed cement by hand on the ground? Yeah, same idea. You make a little volcano and pour it in the middle and keep turning it over. We're adding that water with all those microbes in there. So these microbes, as soon as you add them to the water, start to wake up, mixing them in to a food source. Then they're going to start to grow. Then they're going to start to propagate. Now from then it gets a little bit more. This is like the art and the science part of it. Is you want to make sure that the temperature doesn't get too high. Yeah, I won't go into that too much, but basically you need to keep a small mound because you don't want it to actually compost like thermophilic compost. Once that happens, then the colonies of microbes shift around, and you're trying to keep these microbes that are in there. You're trying to keep that. There's some great videos on YouTube that you can go and have a look at. Chris Trump has some great YouTube videos on how to do all this. So we won't get too much into the detail there. But at the end of that, you have this mound, this batch that should smell nice and sweet, sort of like bread. If you use a wheat product like the mill run or the crushed oats, then it starts to smell like baking bread. It's pretty amazing. So this is IMO3, and then as it's breeding up those microbes, they're using up the water as well, and then it will start to dry out. This is actually 9 months old, so I'm almost ready to make some more. But you want to let them dry out, so they've bred up and then they've dried out again. Then they're they're a bit more shelf stable for a while. Does that make sense? So we've like bred them, put them to sleep, bred them, put them to sleep again, and at each stage, come on through, that's okay. And at each stage, we're putting in the right inputs and trying to create the right conditions that a lot of beneficial microbes are going to be in there, and we know that there's not going to be, I don't like to call them bad, but just say unhelpful microbes. Like we don't really want E. coli in there. Although E. coli is really good in your lower intestine, right? That's where it lives. But you don't want it coming in the top end. So this whole process, this is IMO3, and then you can add it to soil, which makes IMO4, similar process. We're going through that whole process to select for microbes and breed them up. And no, we haven't actually seen with a microscope all of those microbes, although some people have done that, how to look at the microbial constituents. And really one of the main things with the Korean natural farming, different from the other natural farming styles, is being able to create the right environment for a lot of fungal life to happen. So whether that's different kinds of molds, which are lower forms of fungi, or mushroom fruiting bodies, which are the higher forms of fungi, this process creates that. It creates a substrate for those sort of things to thrive. And that's how we're knowing that we're not getting bad microbes in there, right? There's Chris Trump shares a video and does a really good explanation on his macadamia farm in Hawaii. Has anyone heard about that? No, okay. They use the IMO, the indigenous microorganisms, as a trial lot on their macadamia farm, which they had Phytophthora in their trees, destroying some of their trees. And they did it on a little trial lot first. I think it was like 12 or 18 trees to start with. And they started to see these macadamia trees with dieback start to re-sprout again. Now they can't say that they like got rid of Phytophthora, but there's obviously been a balance been put back into that ecosystem where that's been outcompeted and the trees are starting to thrive again. And when they really started to see a difference, when they really converted their whole farm over to Korean natural farming, was when they had a drought and the traditional agriculture trees really suffered. The trees where Korean natural farming was happening, they actually did better in those drought conditions. So there was more of a diversity of ecosystem in that soil for those microbes to actually do their thing and keep the trees healthy. And that's really, to me, that's proof that you feed the soil, you make the soil healthy, and the plants will be healthy. Does that make sense? So I've thrown a bunch of different processes at you. I know it's a lot to sort of catch on to. Again, this is just the intro. So does anyone have any sort of questions about what we've gone through so far? I better check the time that I'm not rambling too much.
The IMO, your collection, Ben, how
Yep.
much rice did you put in there? It's not for my benefit, but for everybody else's. There's a certain airspace you have to have in the box.
That's right, yeah. Yep. So, like I think I might have briefly alluded to, there's a whole, I don't know how much rice I put in there. I just made 3 collections and that was the best one. So, but the idea is that there is actually rice and then an airspace in that box, and that airspace will get some of the humidity of the rice, and then it creates the ideal conditions for those microbes to thrive in there, and it basically attract other microbes into there because it's like, oh, it's a moist, cool, dark environment to live in.
Now, Ben, if we were here, where would you put it? If you had to get the IMOs here.
Okay, so what I've collected here, the best one I did was actually out on this verge here, with all these native trees, and there's a pine tree there as well, but that was the best place that I could find. That
Not
had,
in the midst of that area over there?
we did it over there as well. We did actually do it over
But that
there.
was better?
The collection showed me that was better. So even though we did a couple of collections over there, I think because it has been, people go through that all the time, and things just get thrown there. Lots of just random stuff gets thrown there. That might be part of it. Why it really sort of upsets the balance of the microbes. Over here, no one really ever goes in there. And when I looked visually, I could see mycelium in the soil there. So there was actually a thicker leaf litter. Even though that looks nice and cool and dark over there, that's one indicator. But again, we're trying to get a diversity of microbes, so that's why I did 3 collections here, and I did some other collections as well. As long as it's in the same bioregion, in natural farming they talk about going up, if you have any hills or mountains, go up the mountain, collect some there, go collect some down near the coast, as long as it's in the same bioregion, because then you're getting all that diversity, mixing it together. As you breed it up, you're making sure that those microbes can play together well, and then when you put that out on your soil, you have microbes that are they already know the region, they already know how much water is in that area, how much rain you're going to be getting, all that sort of stuff. And from IMO 3 to IMO 4, you're adding that to the soil that you're going to be farming with. You're actually helping get them acclimatized to
But Ben, if
the
your
microbes.
soil's in a bad way, don't you want to bring in microbes from a place where the soil's better? Where the plant life's better? If we're talking about regeneration and...
Yeah, well, you don't take your collection where there's a Phytophthora outbreak, so you go to a place where you're going to do a collection under a nice, clean tree with plenty of leaf litter underneath it that looks like it's untouched. So yeah, don't do a collection where there's issues with the trees, because you can bring that home and that can cause you issues.
That's where it really pays to be in touch with what's going on, you know, in
Yeah.
tune with nature. It's like, does this look like a healthy tree? Like who's actually seen like a sick plant in nature in an undisturbed area? That maybe there is, but I haven't really seen any. Most of the time, sick plants are in either in agriculture where we're trying to farm them, or in places of destruction, whether that is a volcano or it's just clear cutting or whatever.
In terms
So-
of in terms of diversity though, like I know WA's soils, they a lot of natives here can't process a lot of phosphorus, so that's a big thing that we lack in our soils.
Yeah.
So with the diversity wise, when you do a collection, will those species be able to handle the phosphorus that you'll be having in a setting, more in a productive setting?
Yeah, that's a good question. I don't think I can really speak to that exactly, but I think from my understanding, yeah, let's go collect some from a Banksia woodland, but let's also collect them from up in the hills as well, and try and get a diversity of microbes that can handle what we throw at them. So yeah, I'm not sure exactly about that, whether the native plants and the native microbes could handle things differently like that.
Generally find that the Banksia forests are pure quartz sand.
Yeah.
There's no
There's
goodness in
nothing
them
in
at
there,
all.
yeah.
It's gutless, gutless, gutless. So
Okay, so IMO 1 to 4 we've basically gone through. That's 3, 4. I haven't made that one.
And then what do you do from here? So with this garden here, what would you be doing with these?
Great. So that's the next step. What I do every week, almost every week here, is make a brew. So I'll mix up a 200 litre or 1,000 litre if I'm going to do the whole thing of some of these different inputs and brew this in there. So I use this good old piece of a sweater jumper. Fill that up with the IMO 3 or the IMO 4. Hang it in the brew and aerate it, and let those microbes breed up in there. Or just do an extraction. That difference between an extraction and a brew is an extraction is you're just rehydrating it and mixing those microbes around in the water. A brew is where you actually brew it for 24 to 36 hours, and those microbes are starting to breed up in there. It's another part of the system where you're selecting, but basically you've got this and put it into a liquid form. You can even use IMO 2 to do a brew, to do a simple brew, but just keep in mind as you go through this process, you're actually selecting and creating the right environment for all the beneficial microbes. So then I'll spray that out. I'll do a soil drench. I usually do a soil drench once a week on this section here, and then do a foliar spray and a little bit of a spray out on this section there. So we can use it in a liquid way, in a liquid IMO solution, where we're using some of the other products in there as well. Or you can apply that IMO 4. Last time when I made IMO 4, we spread it and then we mulched over it. So if you think about
is that with soil?
with soil,
Yeah.
that's right. Yeah.
So there's another process from 3 to 4. They add 50% soil, 50% IMO 3,
Yeah.
and let that compost for so many days,
Yeah, that's right. Yeah. Yeah.
and then it gets spread out as a mulch.
I can use number 3 as a mulch, basically, to fit around and then shove some wood chips on the top.
You can do that. But when you go from 3 to 4, again, you're selecting for a certain group of microbes, and you're also introducing the microbes that are already in the soil, so that they sort of, it's called entrainment, and what they've studied with, if everyone's heard of EM, it's a similar thing with EM, is there's microbes. Microbes don't exist in isolation, they exist together in a community. And when you breed up a community, then they know how to work together basically. because they all, like say this microbe is giving this one something and this one's giving that one something, and they all work together. If you just go and throw a microbe in the soil, an isolated microbe, especially like a lab isolated and bred up microbe, maybe all of those microbes are just going to eat that microbe up just as food, and they're not actually going to work together. So the whole idea about this process is you're selecting those microbes that will actually work with what's in the soil. So you can use this. I use this for liquid IMO. I use the IMO3 for liquid IMO. But when you take it through that next step, it's part of the process, and it's a part of a system that has been developed for a while. That we do see good results with that. That's why we're doing it. Some of the guys have gotten into the microscope side and actually had a look at what's going on. Predominantly, it's when you have those beneficial fungi in the soil, then they really help to build the soil structure and help to balance everything else out. So, if you did put this on the soil, you could do that. It's just not necessarily going to work as well in all situations. And this is where it really gets into the subtleties of Korean natural farming. There is like you do want to make sure that there's space in that jar, and there are reasons behind that. It's okay if you don't, but it's not going to work as well. It's like that's part of the system. That's part of the system that's been developed. And what part of the reason I like it, because you have to be in tune with what's going on. You have to be in tune. But start with what you know. Start it and try it out. What I like about the Korean natural farming is you can't really screw anything up too bad unless maybe you did something completely wrong and this went anaerobic and you could smell the ammonia smell coming out of it. Then you might have bred up some microbes that you don't actually want in your soils. But again, we're applying it either as a liquid or by the solid, the IMO4, and then we're trying to look after that soil, build the soil, feed the soil, not the plants, and that's going to.
And then what do you do with so you put it in that stocking, for the want of a better phrase. What do you
Yep.
do with it afterwards? Just put it on the compost, or?
Yeah, well, I've just been playing around, just top dressing other different like pot plants with it, or I've been making fermented clay with that, adding that to clay. So this has already been used up, but it still does have some good microbes in there. But the idea is like you've got that, and you just made 200 litres or 1,000 litres of beneficial microbes out of that one thing, rather than going through all of that, which is actually, if you think about it, a teaspoon of IMO2, you could make like a couple of wheelbarrows of IMO3, add it 50% with or 1-to-1 with soil, and it does build up really quickly, and then you spread that out as an inoculant. You could.
Can you overdose it?
On IMO3 you could, because you could actually throw it on the soil and it'd be so thick that it starts to heat up like compost on the top of the soil. IMO4, I haven't heard that you can overdose it on that. But there is a point where it's beneficial and a point where you're just wasting your product. Do you know what I mean? So, because it is, you got to think of it, it's a seed. It's a seed to get everything going in the soil.
Do you need to repeat the IMO4 process, or it's just once and then it'll be good for years, or once like this?
Until you use it up, yeah, it should be good, as long as it doesn't get wet. If it gets wet, if it's sitting in a bucket or something and it gets wet.
No, what I mean is like you put it on your garden.
Oh, do it, yes.
Yeah, like how often do you need to repeat that process?
Yeah, so here we've done it every 5 or 6 months. Every 5 or 6 months. Basically, every time we're adding new organic material to the soil, that's when we're adding the new microbes. But every every week or so, I am doing a brew on the soil.
You spray once a week this year,
This area here, and they say in the Korean natural farming that it takes about 3 years to really see really beneficial results, where you can see one of the things you can look for is with a penetrometer, where you push a stake down into the ground, you can see the tilth increase. So that fluffiness, the fluffiness that we're talking about, you can see that soil structure increase down into the soil, and that is the benefit of the Korean natural farming system, is that you're building that health down into the soil. Those microbes are getting down. You're building soil structure. The more soil structure you have, the more gas exchange that you have in there. So you have air getting in there, and you have water penetration as well, which is so important. I mean, you get compaction and then you get erosion, and that's damaging a whole planet right now. So you can combat that by getting soil structure, building those microbes, getting those microbes in the soil. Yep.
Question. What are all those magic potions you have, and how do we know which one we need, or how do we make them?
That's a good question. I am going to go into that now. I just wanted to see how much time we have left, because I wanted to focus on the indigenous microorganisms. Some of the teachers say that get this right first, and that's going to help you do all of the other bits and pieces. But we do have 12 minutes left to talk about the rest of it. That's why it's only an intro to Korean.
Just before you go there, you don't have time to make all this stuff up. Where can you buy it from?
I don't think you can buy it. Maybe someone in your areas you're buying it or making it that you could buy.
Not available commercially.
No. The point is that it's local to your region. you
Yeah,
know?
but this region here is the same as it is down in Fremantle or Canning Vale or whatever. So
Yeah.
if someone was making it locally here,
Yeah, well,
You can access it.
I'm starting a service where I do the liquid brews, okay? But again, it's the point is to be able to use what you have around you. So people are doing compost teas, that's great, that's fantastic, that's good biology as well. But there's not anyone selling it here, and in the States there's a few people starting to sell some of that stuff because it's bigger over there. I don't know anybody else that I've met that's been doing it longer than a couple of years here, so everyone's still really just learning the ropes.
finding their way.
Yeah.
Don't think it's really been a commercial sort of option for a lot of people. I mean, I've seen people make biochar and then sell 1 kilo for $25, and I mean, that's not me. I'd rather make it myself where it's free, you know.
Yeah. And that's been the focus, you know, with organisations like YWAM have taken it on board and done missions work with it, you know, where you're actually going into an area where people are literally living off the land and they got to use what they have. That's where it shines first, but then it also does come into like a tree farm like this could really benefit using this fungal diversity in the soil. So let's move on from the IMO and just talk a little bit about all the other ones. This is sort of just my show and tell, but basically we have I forgot that. After I go through them, I'm going to, I laminated a little mixture sheet that you can find on the internet. Just shows you what these things are and how to use them. Okay, so one of the first ones is really great to learn about and use is LAB, lactic acid bacteria. That's a whole group of bacteria. Who's heard of lactic acid bacteria? It's in your yogurt, in your kefir. There's certain strains, but this is a whole family of bacteria. The way that we do that is a similar way of getting some rice water, which has a bit of carbohydrates in there, and then mixing that, letting that ferment for a couple of days, then mixing that with milk. The milk separates. Has anyone ever made cheese before? Yeah. Okay, curds and whey. Yep. So the curds you make in the cheese, the whey has got lactic acid bacteria in there. So if you mix that 1-to-1 with sugar, then you have a shelf-stable product. So this is basically whey, collected in a certain way though, that is lactic acid bacteria. This is a great general all-round, add it to lots of your different brews. It's good for your gut health as well. It actually tastes really nice, like tangy sweet. And that's the great thing about all of these. You can actually, you know, people use this for, what do you call it? Lactose intolerance. You can ingest all of these different brews right there. It's good for you. It's actually good for you.
So the rice water you fermented to turn acidic, is that right? And then you use the acid in that to separate the whey.
Not the acid so much. You're actually collecting microbes.
And
on
the
that.
microbes help
Yeah,
split
from
the milk.
from the air. Yeah, so it would be like similar to that. The microbes get in through that. Then you put it with the milk, and that makes only the lactic acid bacteria flourish. Sort of.
LAB will eat part of the milk too.
That's right. Yeah.
The lactose and the casein.
Yeah. So
Also, it doesn't split like you're making cheese.
It does split.
It does split.
it does. It does split.
That-
But
and
it's a
that's just-
natural. It's a fermentation as opposed to making cheese by adding vinegar.
Yeah. It's like if you added a cheese, whatever, a cheese.
A culture, yeah.
Culture, so it's
Yeah.
a natural culture.
Yeah. So this is a really easy one that you can make, and I recommend that you go have a look on YouTube about how to make that one, because it's good for your gut health, and it's good for the plants. In Korean natural farming, some people call it the police. So that's something that you can come in, and again, you're diluting all of this stuff because it's microbes, right? There's billions of microbes in here right now. Dilute it with unchlorinated water, and you can spray it on your plants. This can help powdery mildew, and it also goes into the soil and sort of starts to outcompete any of the pathogenic or bad bacteria. So this is a good one to make, really easy to make, and it doesn't take as long. It only takes a week to make or so. So that's lactic acid bacteria. Some of the other ones that take a bit longer to make, this is fish amino acids. So we're basically fermenting fish, and it smells like fish sauce. You can have a smell if you like. I actually went on a charter boat and caught some, I didn't catch any fish. Some of the other guys caught some fish. They filleted them, and I said, can I have the rest of the fish because I want to ferment it. So I put it in a bucket, let it ferment 1-to-1 with sugar, with a bit of IMO in there to get the right microbes going in there, and fermented that for 9 months. So, does anyone want to have a smell? It smells like Asian fish sauce, basically.
What were you using
It's not as
for?
strong actually.
Not as strong.
No, it's not.
Yeah, it's not very strong.
Yeah.
It smells nice.
What kind of dilutions?
Okay. No. So the labs are doing 1,000 to or 500 to 1. So 2 mils per liter, or 1 mil per liter for the other ones.
Goes a long way.
It does go a long way. So that's when you can see like this, the OHN. So that took me 3 months to make because it's a tincture with all these different herbs. One of the guys, he actually uses the FAA and he adds that to his kimchi to make.
Oh, yeah. Yeah, my brother puts fish in it.
That's right. Yeah, exactly.
Reminds you like that garum, which is like ancient.
Oh yeah.
That's like fermented fish.
Yeah, that's right. Yeah. Yep.
It smells better than my one.
Well,
I've got a sugarless one.
Sorry?
so that's the thing with the Korean natural farming as opposed to some of the other ones. It's all you're supposed to make it food grade. So use food grade buckets and everything when you do it, which means it's safe for you. So when you're spraying it out, you don't have to worry about what am I spraying out. You also feel good about the fact that you've made all these inputs that you're using with the plants to really to help them to thrive. FPJ, this one is this is pig face that I collected over there because With the FPJ, you're basically looking for plants that are growing vigorously or have some sort of beneficial quality that you want to impart in the other plants. And what you're actually doing, you mix it with sugar again. That sugar draws out the liquid. You leave it in for 7 days. This is FPJ that I did with Italian parsley. Mix it with sugar, sort of like sauerkraut, then put a sugar cap on top. But basically, now I can strain that out, and I'm going to have all of the growth hormones and the secondary metabolites from that plant that are easily available to the other plants. So again, you're using that with unchlorinated water. You're also going to have some microbes from those leaves on there if it's a healthy plant, and that's what you're looking for. You don't want to make an FPJ with a sick plant. You don't want to be like, oh, that one's done, I'll just chop it up and make FPJ. It's like, no, let's like look for maybe a grapevine that looks really vigorous, or when you harvest them, you're always harvesting just the tips of the leaves, you know, there's really growth. So that's what you're getting, and able to foliar spray to other plants that can absorb those metabolites, so things that are already been processed by the plant.
And you see using the microbes on the plant, you're not inoculating with IMO.
We're not inoculating with IMO. Yep. So that's FPJ. The WCA is water-soluble calcium. We get eggshells, just roast them a little bit, try and get that membrane out of them, and mix them with vinegar. In Korea, they use brown rice vinegar, but what I've done here is from all the fruit trees that sort of drop their fruit, that not, you know, that get missed before people pick them, made vinegar. So I made 50 litres of vinegar. This is only half of it, of fruit vinegar. Fruit, and I added some extra sugar. You brew it up. If there's anyone ever done any brewing before, you know, it basically turns to alcohol, and then you leave it open, and then the acetobacter comes in and turns it to vinegar. So that's really easy. That means that we can use that as an input by itself, is the vinegar as an input by itself. You add that to your brews, and they help to acidify the pH, which is what you want when you're aiming for certain things. But then you can use that to extract eggshells. You can actually see the driplets on the outside of there. That's all the calcium that's formed from when it's just dripped down and the liquid is dried. That's the calcium, and that is water-soluble calcium. So that's available to the plant. So, you know, tomato blossom end rot, this is what you need. Again, like, you can use it in isolation, but it works a lot better as a whole part of the system that's been developed. Another one that we'd use for extraction is WCP, water-soluble phosphorus, or calcium phosphate, I think, where you char bones on a barbecue until they're blackened, and then you do an extraction, an acid-base reaction, and get the phosphate out of that as well. So I don't have any left of that because I used some of that up, the rest of that up. But basically, you're making all these inputs yourself. You've got to collect some stuff from around what you have. This one was just an experiment. This is some steak that accidentally got left in the fridge too long, and so I was like, oh, I'm just going to try and ferment that. So I probably wouldn't taste that one, but you know, that's just because I'm playing around. Now I talked about this one. This is a OHN, Oriental Herbal Nutrients. This is like the medicine for the plants. It actually helps to eliminate some of the pathogens, or create the right conditions for the good microbes to work. And now there's 6 of these. There's actually 5 herbs, and each herb I tinctured in alcohol for 2 weeks at a time, times 5 extractions. So this one takes a while to make, as well as the FAA, which takes 9 months to make. But you can get started really easy by just getting that IMO going. Then you can do some FPJ or whatever else. Once you start to build it up, then, I mean, it gives you time to start to learn what's going on. Oh, how does this work? And start to see the nuances of everything. But that is sort of oh, and the other thing that I didn't mention, or I want to mention before, is actually seawater. We use seawater. Why do we use seawater? Does anyone have a guess? We dilute it, but
It's one of the most diverse ecosystems on the planet, isn't it?
it is, yep, it is microbial diverse, but it's also every river runs into, well, most rivers run into the ocean, and we have all those minerals.
Yeah, and seawater's just not sodium chloride. It's
That's right.
Yeah,
It's 90 different minerals in
Yeah,
in
so
seawater.
you pretty much have all the minerals that you need in seawater. So yeah, you don't want to put that neat on your plants. You could try if you want, if you want to kill some plants, but we dilute that 30 to 1. So we usually collect the seawater, leave it out for a day, and that starts to just, microbes start to interact, and then we put it into the brew, or you can do it by itself, but you just got to do it 30 to 1 with unchlorinated water.
And then what, spray it on, or what do you do?
Yeah, you can.
Would you do it on these?
Yeah, yeah.
Really?
We did that. Probably get seawater every month or so, but you could do it more than that. But again, you're just using just a little bit. You're getting those minerals.
30 to 1, did you say?
Yep.
There's I'll get the chart now because I think we've almost finished up for today.
Each week you just kind of alternate what you add to your brew. And if you just have
Yeah.
like a timetable.
We do have a timetable.
And then
This
watch
is when it
what's
starts to
happening.
see, the nutritive cycle theory, where you start to watch what is happening, what time, is things starting to go into flower, into fruit. Is it going into hibernation? Is it, what's happening with the
Yeah,
plant?
it's
So
like kind of like biodynamic, the preparations.
it's very similar, yeah. It's very similar to that. And I think if you know one thing like biodynamics and learn Korean natural farming, you'll see sort of the similarities, and it helps you to see a greater whole picture. So before I finish up, I'm going to get that chart and then I can pass it around to you. Actually, I'll finish up and then we can just have a bit more of a mingle time. So thank you very much
Thank you, Ben.
for
Thanks, Ben.
being here and being part of this, and I hope you're inspired today.